in the case of 1 oxygen lost or 2 oxygens lost. Okay, so we have a question here. How can we determine the charge of the oxyanion variations? So that's a good question. And Emmanuel, the answer for this question is that the charge of the oxoanion is not going to change. Okay, so here you have HClO3. So therefore, the charge of the oxoanion is 1 minus. And even though you added 1 extra oxygen, the charge of the oxoanion is always the same. It's always 1 minus. Okay, so that charge is not going to be changed. And because the order that the book follows is a little bit silly, I cannot show you what's the mechanism that's happening there to keep the charge being the same. Okay, so one trick that you can use in case you forget the charge, look always at the number of hydrogens in the formula. Okay, so if you have just 1 hydrogen, the only possible charge for this cluster here is 1 minus. If you have 2, that will be 2 minus. Okay, so the trick here, if you forget the number of the charge, is to look at the number of hydrogens. All right, so let's move on to the next class of covalent compounds. And so now what I have to show you are the salts containing polyatomic ions. Okay, so actually is ionic compound here. Okay, polyatomic ions, any ion composed by more than 1 element. For example, here, PO4 3-, which is called phosphate. Okay, so because you have a 3- charge here, this charge will be balanced out by a positive element. Okay, and when that happens, you form a compound called salts containing polyatomic ions. Okay, and remember, a polyatomic ion is any ion that is composed by more than 1 element. The nomenclature is going to follow the same nomenclature that we used for salts. The cation keeps the name of the parent element, and the anion keeps its name. Okay, so for example here, let's work with the phosphate. Okay, so if we have PO4 3-, that's going to be phosphate. And Oops, sorry about that. Wrong place. Okay, so PO4 3 minus, that's going to keep its name, which is phosphate. If you have, for example, sodium plus in the structure, that's going to be simply the name of the element, no changes there, and this is going to be called sodium. Okay, so for salts containing polyatomic ions, you have to be really careful with the charges to write the correct formula. So let's work here with two examples. The first one is NaClO3. First thing here, guys, is to identify the polyatomic ion. And that's usually going to be the last two elements in the formula. Okay, so we have here ClO3. From Nick the Camel, we know that ClO3 has a negative charge. And more than that, we know that the name of this oxoanion is chlorate. Because there is a negative charge for the chlorate, someone has to balance out this charge, and that's going to be sodium. Sodium belongs to the group 1, therefore has a +1 charge. So sodium will combine with chlorate. Because the charges are 1 plus and 1 minus, you don't need to write anything. And the name of this compound is going to be the name of the cation, sodium. Give it a space, and then write the name of the oxoanion. And that becomes sodium chlorate. Okay, so the general trend during Chem 109 is that we always start with a very simple example, and then move on to more complex examples, but building on from the start. Okay, so you gotta grasp the initial concept to be able to move on to the more complex knowledge here in this course. Okay, so I want you to pay attention to the second example that we have here. So that's going to be for the compound Na2CO3. Okay, so again, we have 3 elements in the formula that needs to turn on your warning light. And that's probably because we have a salt containing a polyatomic ion. And usually your polyatomic ion is the last 2 elements in the formula. CO3 from Nick the Camel, that comes from CO3 2 minus. And we know that CO3 2 minus is labeled as carbonate. Because carbonate has a charge of 2 minus, someone has to combine with this oxo anion to balance out the charge. And in this case, we are going to combine this anion with sodium plus. So I'm going to write like that, and carbonate 2 minus. You can use the same idea that you used for simple ionic salts. Carbonate, you can read as in need of 2 electrons, and each sodium is capable of donating just 1. So remember that I showed you that you just cross the charges to determine the formula. So that's the same thing you are going to do here. So Na2CO3, that's going to be the formula of the salt formed between sodium and carbonate. And finally, the name for this compound is going to be first the name of the cation, give it a space, and then the name of the oxo anion. Okay, so and then we have here sodium carbonate. Formula for this salt is Na2CO3. Okay, so let's move on. Without a doubt, the hardest part from this chapter is to recognize and name the oxo acids, okay, and all the variations that you may have, and also the salts containing those polyatomic ions. So everything starts knowing the standard, and you can use Nick the Camel. Careful with the charges when you move on to the salts. And then when you combine the oxo anion with a cation, you can follow exactly the same rules and the same ideas that you used for simple ionic compounds. Okay, so one trick here is that the oxo anion will behave as a unit. Okay, so you can think that the oxo anion is one element. Okay, when you need to cross the charges or figure out the stoichiometry of the compound. The nomenclature is the same nomenclature that you used for ionic salts. Okay, name of the cation plus name of the anion. Okay, and finally, the last class of covalent compounds that I'm going to show you are the molecular compounds. Those are the lower class in this family. Molecular compounds are any compound that's not a salt, oxide, or acid, or a base, okay? So it's whatever is left over from salts, oxides, and acids. Molecular compounds are usually formed between elements from groups 13, 14, 15, 16, 17, 18, or hydrogen. The nomenclature for this class of compounds is very, very simple and very similar to oxides. First step, the first word is the name of the first element in the formula. Second step, the second word is the name of the anion, okay, or everything that's not the first element. And then you have to use prefixes to indicate the number of atoms of each element in the molecule. And again, do not use the prefix mono with the first element, okay? So you don't need to do that. So one thing here that you have to be careful is that the second word is the name of the anion, okay? So not the name of the second element. Remember that the name of the anion, if we have a simple anion, is the name of the element with the termination IDE. Okay, so let's tackle the two examples that I'm showing here. So let's start first with BCl3. Okay, BCl3 is not a salt, is not an oxide, and it's not an acid. Therefore, it falls in the molecular compounds category. This compound is formed by boron and Cl minus. Cl minus comes from chlorine. Therefore, we are going to label it chloride. For the name of the compound, we are going to use the name of the first element, followed by the name of the anion, or the second element in the formula, which is chloride. And because we have three Cl's in the structure, we need to indicate using the prefix tri. Therefore, BCl3 receives the name of boron trichloride. Okay. Second example here, PCl5. Let's name this compound. First element in this formula is phosphorus. And phosphorus is bonded with Cl minus. And Cl minus is called chloride. Okay, so remember, it's the name of the element followed by IDE. Therefore, the name of the compound is going to be phosphorus, give it a space, and then write the name of the anion, which is chloride. And you must use prefixes to indicate the amount of each atom in the structure. You just have one phosphorus, therefore you don't need to use the prefix mono for the first element, but we have 5 chlorines in the structure, therefore we need to indicate that in the name. The prefix for 5 is penta. Thus, the name of the compound is phosphorus pentachloride. Okay, so important thing here is to use the adequate prefix. If you have more than one atom for the first element, then yes, you have to use the prefix to indicate the amount. And for the second element, you always use the prefix to indicate the amount of atoms in the formula. And that's how you recognize a molecular compound and name the molecular compound. And again, I just showed you to name a compound knowing the formula, but obviously you need to know how to do the opposite. From the name, write the formula. Okay, so that is all for this chapter. So we are ready to move on to the next. Okay, so let me switch to the PowerPoint. Just a second. Okay. Okay, so that was the last thing. We didn't talk much about compounds containing transition metals. I instructed Liliana, our SI instructor, to go over those kind of compounds, and she will show you how to name them and how to write the formulas. Okay, so that's all for this chapter, and we are ready to start a new chapter. Okay. All right, let's start chapter number 3, stoichiometry. So this chapter is the nemesis of the 109 students. It's a more complex chapter, but again, you understand the basis, then you will be able to ace this chapter. For this chapter, we are going to cover types of chemical reactions. We are going to talk about mole, molar mass, and balancing chemical equations. And the last part of the chapter, we will talk about limiting reactants, percent yield, empirical formula, and percent composition. So that's our goal for this chapter. Okay, so let's start talking about chemical reactions in general. In a chemical reaction, elements will combine with themselves or other elements producing new compounds to achieve stability. Okay, so chemical reactions are driven by stability. Any element or compound will combine to form a more stable product. That's the goal in any chemical reaction. So I'm showing you a general chemical reaction here. We have, for example, an element A combining with an element B, producing a new compound AB2. In red is represented the stoichiometric coefficients. So the stoichiometric coefficients will tell us the amount of atoms of the A element that will combine with the B element and how much will be produced for the product AB2. In this case, we need 1A with combining with 2B to form one of AB2. In blue, we always represent the physical state of each component. S for solid, L for liquid, and if we have a gas, we use G. Okay, so I don't expect you to know the physical state for any reaction. Okay, so we will see that there are some reactions that we need to know and some other reactions that we don't need to know. If you know the physical state, write it. If you don't know, live without it. The left side of the reaction, so everything before the arrow is labeled as reagents, or if you want to use a more elegant nomenclature, reactants. And everything after the arrow are the products. Okay, so let me do a quick switch of screens here, just a second. Okay, so there are four different types of chemical reactions. So I would like to cover those four types of chemical reactions, and then we can finish for today. The first one I would like to show you is labeled combination, or also called synthesis type of reaction. In this kind of chemical reaction, we always start with two or more reactants. For example, A reacting with B, producing only one product. Okay, so we combined the reactants to form only one product. And this kind of reaction is labeled combination or synthesis. The next type is elimination, which is exactly the opposite of combination. For the elimination chemical reactions, we start with one reactant, and after the reaction, we have to produce two or more products. For example, compound AB, for some reason that doesn't matter at this point, after the reaction, produces the compounds A and B. So for elimination, we start with one reactant and produce two or more products. Single displacement. In the case of single displacement, we are going to start with an element reacting with a compound. And in this case, for a reason that doesn't matter at this point, the element A, for example, is going to displace the element B from the compound, and it's going to form a new compound AC and leave B by itself. Okay? Single displacement, one of the atoms in the chemical compound is going to be displaced by another atom. So usually we start with a single element plus a compound, and after the reaction, we produce a new compound and displace the element that was there before. For example, A plus BC, A is stronger than B is going to displace B from the compound and form a new compound AC, and the result is B by itself.
May I ask a question?
And finally, double displacement. For the double displacement case, we start with two compounds, for example, AB with CD, and we are going to displace everybody in the reaction. So in this case, A will switch partners and combine with D, and C will switch partners as well and combine with B. So double displacement, two switches that will produce two new compounds, A with D and C with B. Okay, so double displacement, we start with two or more compounds and everything is going to change. Does someone have a question?
I do. How do you know which element will replace the other element?
So the short answer for this question is that at this point, you still don't know. We are going to cover that in the next chapter, okay? So at this point, I just need you to recognize the different kinds, types of chemical reactions. So it's not the best answer, but is a good answer for the point that we are at.
Okay, thank you.
Okay, you're welcome. Okay, so at this point is just a simple concept. I don't expect you to know who is stronger. You need to look at a chemical reaction and tell me what type of reaction you have. Okay, so I think with that, that's more than enough for today. I will finish it for today, and I will see you back on Friday. Okay, so have a good day. I will see you on Friday.
Thank you, George.
Bye-bye.
Bye.
Have a
Thank
good
you.
rest of your day.
Thanks,
Bye.
Professor.
Thank you. Have a nice rest of your day.
Bye-bye.
Thank you.
I've got a question, Professor, if you have a second.
Of course.
If I remember correctly, we've got, of course, we've got class on Friday. Do we have a discussion on Friday as well, or in-class assignment, or is it just another lecture?
No, this week we have lecture because we had the in-class last week.
Okay.
So remember, that's always alternated.
Oh, okay. I thought it was
Okay.
every week. Okay, thank you.
No, if I wish, but then we don't move with the course. Okay, so we will meet for a regular lecture.
Okay, thank you very
Okay.
much, Professor.
You're welcome.
Have a good day.
You too.